Hi all, moving to the new chapter of organic chemistry, pericyclic reactions. So it is a separate topic of organic chemistry, pericyclic reaction, and a major topic for CSIR net and gate chemistry. Okay, so what is the difference between a normal organic reaction and pericyclic reaction? A normal organic reaction is basically an ionic reaction, and it proceeds through electrophile, nucleophile, in the presence of electrophile, in the presence of nucleophile, and it proceeds through certain intermediates like carbocation, carbanion, free radical, carbene, nitrene, benzene. Such reactions proceeds through these intermediates. But pericyclic reactions are first point, they are concerted reactions, which means the reaction taking place in a single step, and proceeds without any intermediate. So basically pericyclic reactions are single step reaction and there is no intermediate present like carbocation or carbanion. There is no intermediate, single step or concerted reaction. Second point, these reactions takes place in the presence of heat or light. So pericyclic reaction basically takes place in the presence of heat of light. Here the activation energy is in the form of heat or light. The activation energy for the reaction is in the presence of heat or light. So whenever in your CSIR exam, in organic chemistry part, wherever there is heat or light, that is a pericyclic reaction. Okay, wherever heat or light is given, that is a pericyclic reaction. Okay, so this reaction takes place in the presence of heat or light. Third point, they are symmetry controlled reaction. They are symmetry controlled reaction. What is the meaning of symmetry controlled reaction? Whenever you know the stereochemistry of the reactant, then you can predict the stereochemistry of the product. So they are symmetry controlled reaction. Okay, whenever you know the stereochemistry of the reactant, you can predict the stereochemistry of the product. There is a stereochemistry is the most important part of organic chemistry. Okay, basically most important in pericyclic reaction. Whatever the product you obtained, you have to explain the stereochemistry of also. Okay, so we have many short tricks to find the stereochemistry of pericyclic reaction that I will explain later. Okay, so they are symmetry controlled reaction. Fourth point, mechanism is explained by FMO approach. Mechanism is explained by FMO approach. What is FMO? Frontier molecular orbital approach. So these are some important points about pericyclic reaction. First one, they are single step reaction and there is no intermediate present. They are concerted reaction. Second point, this reaction takes place in the presence of heat or light. Third one, they are symmetry controlled reaction. That means when you know about the stereochemistry of the reactant, you can predict the stereochemistry of the product. And the mechanism of these reactions are explained by Frontier molecular orbital approach. The mechanism of these reactions are explained by Frontier molecular orbital approach. Okay. So, pericyclic reactions are of 4 types. In your exam point of view, we have to discuss 4 types of pericyclic reaction. First one, we have to discuss 4 types of pericyclic reaction. First one, electrocyclic reaction. Electrocyclic reaction. Second one, cycloaddition reaction. Cycloaddition reaction. Third one, sigmatropic rearrangement. Sigmatropic rearrangement. And fourth one, group transfer reaction. Group transfer reaction. So these are the 4 important types of pericyclic reactions that is very important for your exam. Electrocyclic reaction, cycloaddition reaction, sigmatropic rearrangement and group transfer reaction. Among these, electrocyclic reaction is the most important. Okay. So electrocyclic reactions, 2 types they are. Electrocyclic ring closure reaction or electrocyclic ring opening reaction. 2 types of electrocyclic reactions are there. Electrocyclic ring closure and electrocyclic ring opening. All the details that we will study later. Okay. So we have to discuss one by one. In the first lecture, I will start with the most important electrocyclic reaction. Then in the coming lectures, we discuss about the cycloaddition, sigmatropic rearrangement and group transfer reaction. So a basic introduction. First one, electrocyclic reactions. Electrocyclic reaction is basically shown by a conjugated polyene, shown by a conjugated polyene means the molecule containing more than one double bond, and it is shown by a conjugated polyene, double bond, single bond, double bond, single bond, double bond. So whenever in your question paper there is a conjugated polyene is present, that reactant shows electrocyclic reaction. Second reaction is cycloaddition. Cycloaddition reaction. Cycloaddition reaction is shown by a diene. This is a diene and this is a dienophile. So whenever a diene react with the dienophile, this is diene and this is dienophile, that reaction is called cycloaddition reaction. Third one, sigmatropic rearrangement. Sigmatropic rearrangement. Sigmatropic rearrangement. Shown by allylic systems. Sigmatropic rearrangement is shown by allylic system. For example, what is the allylic system here? Allylic system is the third position from double bond. 1, 2, 3. This is an allylic system. 1, 2, 3. This is also an allylic system. When you are numbering from double bond, 1, 2, 3. Third position from double bond is called as allylic system. So, sigmatropic rearrangement is shown by those molecules which are having allylic system. So, this molecule shows sigmatropic rearrangement because there is an allylic system present. And fourth one, group transfer reaction. Group transfer reaction. For example, here a group G is present. Here a group G is present. This one on reaction with a diene like this. What happens? This sigma bond shifted towards this carbon. Here this pi bond make a bond here, and this bond catch up this group. So what do you get? This is the electron shifting. Sigma bond shifted towards here, this pi bond make a bond here, and this pi bond attack this group. So you will get here a pi bond is there, and this group is transferred to this part. So group transfer reaction. Such reactions are called group transfer reaction. So electrocyclic reactions, cycloaddition reaction, then sigmatropic rearrangement, and group transfer reaction. Electrocyclic reaction is shown by conjugated polyenes. The cycloaddition reaction, whenever a diene and a dienophile reactant, they form cyclic adduct. Okay. Then sigmatropic rearrangement is shown by allylic system, and these type of reactions are called group transfer reaction. A group is transferred from one molecule to the one part of the molecule to the other part of the molecule. Okay, so that is a basic introduction about pericyclic reaction. So moving to the very first type of reaction, electrocyclic reaction. So electrocyclic reaction is shown by what type of system? Conjugated polyenes. Reaction taking place in the presence of heat or light. So consider a conjugated polyene. This is a conjugated diene in presence of heat or light. What is the product? What is the product? So electrocyclic ring closure. Here ring closure takes place because this is an acyclic system. Here ring closure takes place. So the electron shifting is like this. This pi bond shifted towards this carbon, and here a sigma bond is formed. So you will get a 1, 2, 3, 4 membered ring with a double bond here. Okay. So how many sigma bond and pi bonds are present in this molecule? 1, 2, 3. 3 sigma bond, 3 carbon-carbon sigma bond, and 1, 2 pi bond. 3 sigma bond and 2 pi bond. How many sigma bonds are present here? 1, 2, 3, 4. 4 sigma bond and 1 pi bond. Sigma bond between carbon-carbon sigma bond. Carbon-carbon sigma, carbon-carbon sigma, carbon-carbon sigma, carbon-carbon sigma. 4 sigma 1 pi, here 3 sigma 2 pi. So as a result of this pericyclic reaction, one of the pi bond is converted into a sigma bond. Okay, as a result of pericyclic reaction, here two pi bonds are there, but in the product there is only one pi bond. This is the newly formed sigma bond. Is it? So one sigma bond is formed at the cost of one pi bond. So one of the pi bond is converted into a sigma bond. Then what about this example? This is a conjugated polyene. So in the presence of heat or light, definitely what type of reaction that molecule will show? Definitely an electrocyclic reaction, electrocyclic ring closure. This pi bond is shifted towards here. So ring closure takes place. 1, 2, 3, 4, 5, 6. A six-membered ring. We can give a number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So between 2 and 3 a new bond is formed. Between 4 and 5 a new bond is formed. Between 1 and 6 a new sigma bond is formed. So between 1 and 6 this is the newly formed sigma bond. So these types of reactions are called electrocyclic reaction, and this is electrocyclic ring closure, ring opening, that we will study later. So in electrocyclic reaction, one of the pi bond is converted to sigma bond. Here 1, 2, 3 pi bonds are there, but in the product there is only 2 pi bond. The remaining 1 pi bond is converted into a new sigma bond. So these types of reactions are called electrocyclic reaction. So in CSIR exam point of view, we have to discuss three things. When you are studying about electrocyclic reaction, we have to discuss about three things. First one, type of system. In order to study electrocyclic reaction, the first thing that you have to study is type of system. For example, two types of systems are there. Foreign system. This is a foreign system because how many pi electrons are there? 2 plus 2, 4 pi electron. If the number of pi electron is a multiple of 4, then that is a foreign system. 2 plus 2, 4 pi electrons are there. When n is equal to 1, 4 into 1. So this is a foreign system. Second type of system is foreign plus 2 system. This is a foreign plus 2 system. Because 2, 4, 6 pi electrons are there. 2, 4, 6 pi electrons are there. So that is a foreign plus 2 system. So type of system, two types of systems are present. Foreign system and foreign plus 2 system. Second thing that you have to remember is, or we have to study is their mechanism. Explained by FMO approach. Mechanism explained by FMO approach. Okay. Third thing that we have to study is their stereochemistry. The stereochemistry is the most important part in electrocyclic reaction, but don't worry, we have a short trick to predict the stereochemistry of any electrocyclic reaction. Okay, we have a short trick to predict the stereochemistry of any electrocyclic reaction that I will explain later. So, while studying electrocyclic reaction, these three things are very important. First one, what is the type of system? Whether it is a 4n system or 4n plus 2 system, whether it is a conjugated polyene or a conjugated ion or a strained system, like that I will explain. Then the mechanism of electrocyclic reaction is explained by Frondlier molecular orbital approach. And the last one, what about the stereochemistry, most important part. So first one, type of systems. We have to discuss about 4 types of system. First one, polyenes. A typical system which shows electrocyclic reaction is polyenes, and simply first one, acyclic polyenes. First you have to study the system, then only you can predict. In your CSIR question paper, a molecule is given, whether this molecule shows electrocyclic reaction or sigmatropic rearrangement or cycloaddition or group transfer reaction. You can predict only if you study the type of system which shows electrocyclic reaction. First one, acyclic polyenes. For example, 1,3-butadiene. What type of system? This is a 4n system because there are 4 pi electrons present. Next system, 1,3,5-hexatriene. This is a 4n plus 2 system. 1,3,5-hexatriene, which is a 4n plus 2 system. How many pi electrons are there? How many carbon? 1, 2, 3, 4, 5, 6, 7, 8 carbon. Then 4 pi electron. This is also a 4n system. An example for a 4n system. Another example. How many pi electrons are present? This is also a multiple of 4n system. Another example, how many pi electrons are present? 2, 4, 6 pi electron. So this is an example for a 4n plus 2 system. Another example, here 1 pi electron. So these are some typical examples of acyclic polyenes which shows electrocyclic reaction. Okay. Then cyclic polyenes. Cyclic. First example, how many pi electrons are there? 2, 4 pi electron. So this is a 4n system. This is an example for a 4n system. Next one, how many pi electrons are present? 2, 4, 6 pi electron, which is an example for a 4n plus 2 system. How many pi electrons are present here? 2, 4, 6. So an example for a 4n plus 2 system. Another example. Two, 4, 6. This is also an example for 4n plus 2 system. So these are some cyclic polyenes which shows electrocyclic reaction. Second type, after polyene, the second type of compounds which shows electrocyclic reaction is conjugated ions. Conjugated ions. Second type, B, conjugated ions. For example, conjugated ion. What type of system? This is a conjugated ion. Double here, a positive charge is there. Here 2 pi electrons are there. So this is an example for a 4n plus 2 system. Then another example, minus. How many pi electrons are there? 2, and this minus also 2 electrons, so 2 plus 2, 4 electron. So this is an example for a 4n system. 4n system. Another example, plus. How many pi electrons? 2 plus 2, 4 pi electrons. So an example for a 4n system. Another example, minus. How many pi electrons? 2, 4, and this minus also 2. So 6 pi electron, which is a 4n plus 2 system. So these types of conjugated ions also shows electrocyclic reaction. Okay, instead of conjugated polyene, this type of conjugated ions also shows electrocyclic reaction. Remember, whenever in your CSIR exam question paper these type of conjugated ions are there, they will also shows electrocyclic reaction. Next type, C, third type, doubly alpha beta unsaturated ketones. Doubly alpha beta unsaturated ketones. For example, this is a ketone, C double bond O. This is the alpha carbon and beta carbon. In alpha and beta there is unsaturation. So this is an alpha beta unsaturated ketone, doubly alpha beta unsaturated ketone, because 2 double bonds are there. Okay, doubly alpha beta unsaturated ketone. This compound also show electrocyclic reaction, a special type of reaction, Nazarov cyclization, a named reaction. Nazarov cyclization. This name reaction that we will discuss in this lecture, Nazarov cyclization, which is shown by doubly alpha beta unsaturated ketone. Doubly alpha beta unsaturated ketone. Another example for a doubly alpha beta unsaturated ketone. This is also a doubly alpha beta unsaturated ketone, which is shown a special type of electrocyclic reaction called Nazarov cyclization. Nazarov cyclization. So that is the third type of system, doubly alpha beta unsaturated ketone. Fourth one, strained ring. Strained ring systems. Strained ring system. Strained ring system means 3-membered and 4-membered ring are highly strained. 3-membered and 4-membered ring are highly strained. For example, this is a 3-membered ring. This is a 3-membered ring which is highly strained. This ring will show electrocyclic ring opening reaction and electrocyclic reaction. Then another example, minus 3-membered ring, highly strained. This will also show electrocyclic reaction. A 4-membered ring, highly strained, that will also show electrocyclic ring opening reaction. So, my dear students, what are the 4 types of system that will show electrocyclic reaction? What are the 4 types of, then only you can answer the question. First of all, in your question paper, you have to identify whether this is electrocyclic ring reaction or sigmatropic reaction or a group transfer or a cycloaddition. First of all, in order to show a molecule electrocyclic reaction, the first condition that what are the 4 types of system? First one, polyene, acyclic as well as cyclic polyene. Second one, conjugated ions. Third one, doubly alpha beta unsaturated ketone, a special type of electrocyclic reaction called Nesterov cyclization. And fourth one is a strained ring. 3-membered and 4-membered ring are highly strained. Such a type of systems called shows electrocyclic ring opening reaction. Okay, then examples. Some examples of electrocyclic reaction. We discussed the type of system which shows electrocyclic reaction. First example that I already discussed, 1,3-butadiene in presence of heat or light. This is a conjugated polyene. Definitely what happens? Here cyclization takes place. Pi bond shift towards here. Here a new sigma bond is formed between first and fourth carbon. So a 4-membered ring, here a double bond. Okay. So 1,3-butadiene on electrocyclization to form cyclobutene. Second one, 1,3,5-hexatriene. 1,3,5-hexatriene in presence of heat or light. How many carbon atoms are there? 1, 2, 3, 4, 5, 6 carbon atoms are there. So this pi bond shifted towards here, this towards here, and here a new sigma bond. So a 6-membered ring is formed. Only 2 pi bond, and this is the newly formed sigma bond. Then third example. Sorry. What about the electrocyclization in this molecule? Electrocyclization. This pi bond towards here, this towards here. This pi bond makes a sigma bond between these 2 carbon. You can number the carbon 1, 2, 3, 4, 5, 6. So a new sigma bond is formed in the presence of heat or light. A new sigma bond is formed between 1 and 6, first and 6th carbon. So this is the first carbon and 6th carbon. Here a new sigma bond is formed. Between 2 and 3 a new pi bond. Between 4 and 6 a new, 4 and 5 a new pi bond. So that is about the electrocyclization of that molecule. Then fourth example. In presence of heat or light. What is the product? In presence of heat or light. Cyclization. This pi bond towards here, this towards here. Here a new sigma bond between these 2 carbon. So cyclization to form a 6-membered ring. 6-membered ring. Here a new pi bond. Here a new pi bond. This is a new sigma bond. Here a methyl group. Here a methyl group. That is the electrocyclization of that molecule. Next example. Fifth one. Here a double bond, double bond, double bond. In presence of heat or light, what is the product? In presence of heat or light, what is the product? Cyclization takes place because this is a conjugated polyene. This towards here, this towards here. Here, between these two carbon, a new sigma bond is formed. You can number 1, 2, 3, 4, 5, 6. So, between 1 and 6, a new sigma bond is formed. Between 1 and 6, a new sigma bond is formed. So, this is the newly formed sigma bond. Then, between 2 and 3, a pi bond. Between 4 and 5, a pi bond. This is the newly formed sigma bond. Newly formed sigma bond. So that's about the electrocyclization of that molecule. Then sixth one. What about the electrocyclization in this molecule? Electrocyclization in this molecule. You can number the pi electron. First pi bond is here. 1, 2, 3, 4, 5, 6. In this carbon there is no pi bond. So cyclization is like this. This pi electron shifted towards here. This pi electron shifted towards here. This pi electron make a sigma bond with the first carbon. Okay, this pi electron make a sigma bond with the first carbon. So a sigma bond is formed between first and the sixth carbon. So you can number 1, 2, 3, 4, 5, 6. Between 1 and 6, a sigma bond is formed. So in presence of heat or light, a six-membered ring is formed. A six-membered ring is formed. You can number this as 1 and this as 6. So between 1 and 6, a a new sigma bond is formed. This is 2, 3, 4, 5. What about the new pi bonds? Between 2 and 3, a pi bond. Between 4 and 5, a pi bond. Between 1 and 6, the new sigma bond. Then the remaining portion of the molecule, 1, 2, 3, 4, a 4-membered ring. 1, 2, 3, 4-membered ring. 1, 2, 3, 4-membered ring. So that is the product. That is the product. So after electrocyclization of this 8-membered ring, a 6-membered and a 4-membered is formed. Okay, because here new sigma bond is formed between 6 and the first carbon. The remaining portion is a 4-membered ring. 4-membered ring. So that is about the electrocyclization of some common molecules.